So let's read the question. In the given figure, AB is a line segment and line L is its perpendicular bisector. If a point P lies on it, show that P is equidistant from A and B. So a lot of fancy terms in this question. Let's understand them one by one. So in the given figure, AB is a line segment, no problem. And line L, that is this line over here, red line, is its perpendicular bisector. So one word at a time. Perpendicular means the angle between this line and AB is 90 degrees, right? So this angle is 90 degrees and this angle is 90. So what is the meaning of perpendicular? If one line is perpendicular to the other, that means, for example, line L is perpendicular to AB. That means the angle between line L and AB is 90 degrees, like this over here. Next, bisector. Bi means to, sect means to cut. So what does a bisector do? It divides the part it is cutting in two equal parts. So line L is cutting AB. That means it is going to divide AB in two equal parts. So let's say this point over here is point D. That means AD is equal to BD. I repeat, what is a bisector? See, bi means to, sect is to cut. So it is cutting AB in two equal parts. That means AD is equal to BD. So line L is a perpendicular bisector. Perpendicular means angle is 90. Bisector means it is dividing AB in two equal parts. So AD is equal to BD. Next, if a point P lies on it, so this over here is point P, show that point P is equidistant from A and B. Equidistance means the distance of P from A is equal to distance of P from B. Equidistance from 2 points means the distance of point P from A. What is the distance of point P from A? PA. This, and what is the distance of point P from B? PB. So we want to show that point P is equidistant from A and B. That is basically we have to show that PA is equal to PB. Right? So this is what is meant by the question. So first step is always understand your question. So now let's begin with what is given to us. So what all is given to us? L is the perpendicular bisector, so these two angles are 90. So write it over here. That is angle ADP is equal to 90 degrees. Angle BDP is equal to 90. Right? Next, AD is equal to BD. So AD is equal to BD. So this over here is given to us. You can also mention in bracket, that is line L is the perpendicular bisector. So what is the reason? Line L is the perpendicular bisector. So perpendicular, this is the symbol, is the perpendicular bisector of line segment AB. Right? Next, what do we have to prove? So we're done with given. Next, to prove. So we have to prove P is equidistant from A and B. That is basically we have to show PA is equal to PB. So to prove PA is equal to PB. So now let's begin with the proof. Given, done, to prove, done. Now let's begin with the proof. So see, how do I prove that PA is equal to PB? Notice carefully, we have two triangles over here. I repeat, we have two triangles over here. So if I can show these two triangles are congruent, then automatically PA will become to PB. Right? So now, how do I prove these two triangles to be congruent? See, what do I know? AD is equal to BD. One side is known to me. Next, this angle is equal to this angle. Angle is known to me. So if I can show this side to be equal, we'll get SAS criteria. Is this side equal? Yes. Why? This side over here, PD is a common side. PD is common to both this triangle and this triangle. I repeat, look at the two triangles, ADP and triangle BDP. In these two triangles, one side is equal, one angle is equal, and this side is a common side. So this side is also equal. So what do we notice? Side, angle, side. So these two triangles are congruent. So how do we prove it? Begin with congruence. So in these two triangles, in triangle ADP, so in triangle ADP and triangle BDP, what all do I know? AD is equal to BD. Next, angle ADP is equal to angle BDP. Why? This over here is given to us. So you can mention in bracket, given. Next, what else did we conclude? PD over here is the common side. So how do we write it? We say that PD is equal to PD. What is the reason? Common side. So what do I notice? In two triangles, if two corresponding sides are equal and the included angle, very important, and the included angle between the two corresponding sides are equal, That means the two triangles are congruent. Which criteria? SAS. See, S, A, S. So the two triangles are congruent. Now be very careful while writing the congruence statement. So select any one of these sides. Let's say select this. So I'll write triangle AD is congruent to triangle BD for the time being, right? Now just label this 1, 2, 3 and 1, 2, 3. So AD is equal to BD, fine. Angle ADP, that means basically angle D of this triangle should be equal to angle D of this triangle. Let's see. Second letter D corresponding to second letter D. Perfect. So now what is left? P. P over here, P over here. Let's verify. What is the side corresponding to PD? PD is what? Second and third letter. This will correspond to second and third letter. What is second and third letter? PD. So we're getting PD is equal to PD. So verify all the three things. AD should be equal to BD. AD, first two letters is equal to first two letters BD. Check. Angle D is equal to angle D. Second letter is equal to second letter. Check. PD should be equal to PD. PD means second and third letter. This will correspond to second and third letter PD. So all three check. So this over here is a congruent statement. And what is the criteria we've used? SAS. So mention SAS congruence rule. So writing the congruent statement is a bit tricky, but slowly you get the practice of it. It's very simple. Just begin with this, verify and just check if all your three conditions are met or not. So these two triangles are congruent by which rule? SAS congruence rule. Now the important thing, we have to get PA is equal to PB. So how do I get that? Get the corresponding part. Look for PA. What is P over here? See, PA. So PA is what? Third and first letter. So third and first letter will correspond to third and first letter. I repeat, based on the congruence statement, what is P over here? Third and first letter. So third and first letter will correspond to third and first letter here. What is third and first letter over here? PA. What is third and first letter over here? PB. So what do we get? PA is equal to PB. So I'll write it over here. That is PA is equal to PB. Why? Once you have your congruent statement, if you're able to conclude something else, what is the reason behind this? CPCT. That is corresponding parts of congruent triangle. So whenever two triangles are congruent, all the three corresponding sides are equal. So if this is equal to this is equal to this has to be equal to this, which is there from the congruent statement. So P is equal to PB, CPCT, hence proved. So this is exactly what we wanted to prove. So P is equal to PB, hence proved. So this is how you solve this question. So let me do a recap. First step is always understand your question. Line L is the perpendicular bisector. Perpendicular means this angle is 90. Bisector means it is cutting AB in two equal parts. So AD is equal to BD. Now we want to show PA is equal to PB. So how do we do that? I see two triangles over here. Try to prove them as congruent. This side is equal to this side. Angle is equal. And this over here is a common side. So by SAS criteria, these two triangles are congruent. The moment two triangles are congruent, all three corresponding sides have to be equal. That means if this is equal to this is a common side, this has to be equal to this. And we can get it from the congruent statement. Look for P over here, first and third letter. This will correspond to first and third letter here, that is PB. So we're getting from the congruent statement, PA is equal to PB, CPCT, that means corresponding parts of congruent triangles. Hence proved, right? So this is how you solve this question.